Actually, in China, it's afternoon. China is fast 5 hours than Iraq.
Okay.
So good afternoon.
Good morning in our side. Good afternoon in your side.
Yeah. In China, it's afternoon, and in your country, it's morning. Yeah.
I think the China's time is the same as Malaysia, right?
Malaysia.
Malaysia.
Yeah, right.
Malaysia.
Yeah, right.
Yes.
The same time zone. Malaysia.
Yes. Huawei also have a training center in Malaysia.
Yeah.
Have you been to there?
Yeah, my PhD was there.
Oh, yeah. Okay. And in China now it's summer, so outside is very hot. And what about your country's weather? In your country?
Very hot.
Very hot.
Yeah, above 40.
Oh, similar to China. China 38.
Above 40. Maybe after 2 hours only 43, 44.
Oh, too hot. We can't. We didn't go out. We just stay at the office or at home whole day.
That's right.
Yeah. Okay. Please.
Okay.
Okay. Let's start our course now. And I see some teachers didn't attend our online meeting. Yesterday there are 50 teachers, but now only have 38.
Yeah.
How about yesterday's content? And everyone can follow me?
It was very testing, but I think, because of most questions from the teachers, so we couldn't complete all slides, right?
But I think if we can discuss, I think it's better to digest the content. I think you don't worry. We can finish the content. Okay?
I hope so. Okay, thank you.
Yeah, because some materials just we can study by myself. But some contents I should teach in detail. Okay.
Okay.
Okay. Next, we start our course. Yesterday we have learned about what's the 5G and what the 5G can do, like the VR, AR, like the automatic driving, like the large connection, like smart city, like intelligent meter reading, and so on. Now next, I will introduce some technologies about our 5G from this picture. And structure the NR technique framework, new wave 4, new wave 4. New wave 4. You know, in our 4G, we use the OFDM, OFDM. But for our 5G, we use the FOFDM. And F means the filter, filter. Compared with the OFDM, FOFDM have a higher efficiency. So we call it new wave 4, new wave 4. And the numeric free structure, free structure. You know, in our 4G LTE, we just support one free structure, just 15 kilohertz, one subcarrier, But in our 5G, we can support 15 kilohertz, 15 kilohertz and 30 kilohertz. And 16 kilohertz. So different service, we can use different free structure. So it's the 5G. Why we say 5G can support the low latency. One reason is that they can support the numeric, have different subcarriers, and coding, modulation and channel coding. You know, in our 4G, we just support 256 QAM. But for our 5G, we can support 1080 QAM, 18 QAM. And this is a modulation, And the coding, in our 4G or 3G, we just support the turbo coding. But for our 5G, we can support the LDPC and Polo code. And the LDPC is used suitable for the EMBB service, and the Polo code is suitable for the control signal. And the massive MIMO, is one the key technology that can increase the ping rate. You know, our 4G they can support 44R, 44R. But for our 5G, we can support the 1640 and 16.4R. 16.4R. This is the massive MIMO. It can improve the throughput. And the flexible duplex. And in our 4G, you know, in our 4G, we just up and down. In our 4G, 1 sub 3 just can support the uplink or downlink. But for our 5G, or 5G, and one sub-free. For our 5G, one sub-free. One sub-free can support uplink and downlink signal in the one sub-free. So it also can reduce the delay in some URLLC scenarios. And this is the NR technique framework, and this technology, and I will introduce later. Introduce in detail later. And network architecture ready. 5G support uplink and downlink decoding. This standard announced by Huawei company.
Please, one question.
Please.
About the slot for 5G. Yes. Slot can be divided. The same slot can be divided to the uplink and downlink for 5G.
Yes. One sub-free.
Equally with the same amount of time.
Yeah. In sub-free. Yeah.
So thank you.
Yeah. And later I will introduce the advantage is that can reduce the latency, because the uplink and the downlink, there are guard band or there are the delay between the uplink and downlink. But if we put the uplink signal and downlink signal in one sub-free, and it can reduce the delay between the uplink, so can reduce the latency. Okay, and next is uplink and downlink decoding. Decoding. In our network, uplink. This is base station. And this is UE. And in our 5G network, we usually use the 3.5 GHz. This frequency band for coverage. But this is 3.5 GHz is a high frequency band. In our 4G frequency band, usually is 1.8 gigahertz for 4G's frequency band. If the 5G, if the base station use this frequency for coverage, downlink is no problem. But because the base station have enough power to support the coverage. But for our UE, if the UE is far away from the base station, if we still use the 3.5 gigahertz, this frequency band for coverage, may the signal is weak if the UE is far away the base station. If UE far base station, because the UE's power is limited. If it uses the high frequency band, may the signal is weak. So we can select the low frequency band, or we can use the 4G frequency band 1.8 gigahertz for coverage. The low frequency band have a good coverage compared with the high frequency band. So for downlink. For downlink, we use this frequency band. For uplink, we use this frequency band. So this is we call it the uplink and the downlink decoupling. And CU and DU high-level segmentation. Is also cloud LAN. Actually, maybe in the future, we just deploy CU near the application, near the customer, and the DU deploy in the center machine room, and DU will be clouded. It can also meet the requirement like some URLLC service. It need low latency and it more safety. The then is NSA and SA. NSA means the non-standard log. SA means standard log. These two networking mode. NSA just in the early stage of 5G deployment. In the early stage, we must deploy the 5G base station with the 4G, and with the development of 5G, and we just need to deploy the 5G base station and the core network independently. And URLLC, industry basic design. In some factory, if you want to control the robot or machine remotely, so you need the URLLC. And the new multiple access, like the SCMA, this multiple access. It means the sparse code multiple access. This access technology used for IoT, because it has a large connection.
Excuse me. Hello.
Please.
Regarding CU and DU.
Oh yeah, this one.
Central unit and is it central unit and distributed unit, right?
Yeah.
So
the central unit and the distributed unit. Yes.
Yeah, what I understood, you mentioned that CU is put in the edge, right?
No. Sorry. DU distributed, deployed in the edge. Near edge. Yeah. Near the user, near the application. Yeah. Sorry.
Okay. And CU should be in the central DC.
Yes.
Central data
DC.
center.
Yes.
For real time and non real time, data. Broadcasting. Yeah. Thank you.
Yeah. One CU and multiple DU. Yeah. And this is cell backhaul. It used for the transmission. And MMTC for the IoT. And D2D means device to device communication. And V2X, it means the vehicle to everything. We can use the actually R16, R14 can support the V2X. And unlicensed means it the network can use the public frequency like the Wi-Fi frequency 5G gigahertz. They can aggregation, or they can cooperate it together, like operated use the public frequency and private frequency. This is the unlicensed. And this technology, and I will introduce in detail later. And next, first is the 5G networking mode. There are two modes have said. One is NSA, another is SA. NSA means NSA means a non-standalone networking architecture. Non-standalone. In the earlier stage, we have deployed the 4G network where all the country, all the world have deployed the 4G base station. And if we want to deploy 5G base station, we can't replace the LTE base station, because operator have invested a lot of money in 4G. So it make a solution that deployed with the 4G, like this picture. And the 5G base station deployed with our 4G base station. We call it non-standalone. And in this networking mode, we just support EMBB scenarios. And 4G base station plus 5G base station and 4G core network. And this is S1. This dotted line. Dotted line is S1 for control plane. And this sorted line is user plane. Is S1 for user plane. Actually, in our 4G network, the S1 have the control plane and the user plane, but if we deploy the 5G, deploy the NSA network, and the user plane will be here. This is the user plane. Connect with the 5G base station. This 5G base station is the data split. It's the data split. It's the data split. Is the data split, and the data will go through the 5G base station, and 5G base station is a data split, and some data goes through the 4G base station, then to the terminal, to the UE, to the UE. But the control plane, also use this one, this S1 control plane. This is the sorted line. This is the control plane. Go through the signaling. But for control plane, the EPC to the 5G base station, then some user data goes through the 4G base station, and some some user data goes through the 5G base station, and then to the UE. We call it MSA. MSA means the multiple stream aggregation. To implement collaboration between the two modes. This is the NSA, and the data stream can be splitted in the 5G base station. And if the UE if the UE in the 5G coverage area, the UE use the 5G base station signal. And if the UE go out the 5G base station to the 4G coverage area, and the UE will just use the LTE's coverage signal. So this is the we call it NSA networking. Okay, about NSA, I have any question?
Yes, please.
Please.
Would you mind? Just two questions briefly. We mean our 5G coverage area or base station is not continuous just inside LTE?
Yeah.
This is the first.
In the early stage, the 5G base station is not enough, and the signals can't be continuous. So it will be the 5G and 4G together provide a service for the UE.
Yeah, just let's say it's similar the first generation, just one base station, not in coverage all region. Just inside LTE.
Yeah.
Second,
because list mode, we often provide service for the hotspot, like the supermarket, like the cinema, like the gym. So it's just a hotspot.
Yeah. Second thing about the control plane, just control signal just coming from LTE only, not from 5G base station.
Yes, because in control plane, we can't interrupt. It can't interrupt. 4G network is deployed very well. If the control plane in the 5G base station, and if the UE go out the 5G base station coverage, may it interrupt. So the control plane must be in the 4G network. Okay.
Even the control plane is belonging to the 5G must be passed through the LTE.
Yeah.
Thank you.
Yeah, through the LTE. Yeah.
Excuse me.
Please.
You talked about the anchor point. The yellow color is serving as an anchor point, which is the 5G G node B. So in this scenario, the user has the 5G and LTE transceiver. So for dual connectivity, connecting with the 5G and LTE, when the user intends to connect to one of them, so of course we have handover. So can you tell me, in terms of the handover, how at the core layer, how such kind of handoffing service can be guaranteed between 5G to LTE or vice versa?
Okay. You mean the handover, really?
Yeah, at the core network.
In core network, the mobility management, how to like the 4G base station hand over to the 5G base station, or the 5G base station to the LTE base station. Really?
Yeah, perfect.
Yeah. You know, first one, the UE access into the 4G base station. UE access into 4G base station. Set up the RC connection, and then the UE will measure. The second, the UE will measure the measure MEASURE. The measure the 5G signal. Then the UE report the measure report. The UE measure report the MR the measure report to the MR measure report to the 4G and the 4G at the 5G at the main base station at the 5G at the base station at the main base station and then UE access into the 5G for user play. And the UE access into 5G in user play. Actually, they in the control plane goes through the LT, and LT base station set up the handover, set up the mobility management. Yeah.
Mm-hmm. Yeah. Thank you. Yeah.
Okay.
Okay. Yeah. Thank you.
Okay. And the next is SA, and SA is very simple. The 4G base station and the 4G core network, and the 5G base station and the 5G core network. For SA can support EMBB, URLLC, and MMTC. You know, in this year, China's operator started to deploy the SA networking. The NSA networking is just at the beginning. It's just the early stage. And the next time, and for the in the several years, the operator started to deploy the SA network. And this NGC is, we call it control plane. NG next generation control plane, and NGU is user plane, and NG core. We can also 5G NGC. We call it SA network. Okay, this is about the SA and the NSA. Okay, have any question?
Thank you.
Okay. Actually, this mode for the SA, for the NSA and SA, there are multiple modes in our defined by our 3GPP, and the main used, the popular used is option 3. Option 3. Option 3 and option 3A and option 3X. Actually, there are many options like option 1, option 2, option 4, option 6, option 7. And the widely used is option 3X. In our Reality network, we use the option 3X. 3X is this one. Option 3X, this one. And option 3, means use the EPC, EPC, and this is the control plate and the user plate, and this is LTE base station, and this is 5G base station, NR, X2 control plate, X2 user plate, and the UE. And for this mode, the LTE base station is the data split. Data split. And why? Actually, in our Reality network, we use option 3X. And why we didn't use the option 3? Why? We can discuss why the network, the operator can't select this mode. Any in training can answer my question?
Maybe because of the backhaul?
Backhaul?
Backhaul.
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 Backhaul? What's the backhaul?
Backhaul.
It means the interface between the user and the station.
Because LTE upgrades are needed, and also it puts too much pressure on the transportation of the informations.
Yeah. It's one reason. Yes.
Because the LTE network cannot support the 5G version, which is the data comes from 5G users cannot be supported by the LTE network.
Yes.
Also, maybe the data coming from the 5G is not separated. The one slot have uplink and downlink, not the same as the LTE.
Yeah.
And I think, sorry, can you hear me?
Yeah.
Okay, I think one of the options regarding to why they use option 3, I think the network in option 3 have the both LTE and NR radio access. So I mean, like the core LTE to route control signaling is one of the issue for having or using the option 3.
Yeah.
And I think like this was lead us to like using this option will have like most interactive like how can I say for the operation for deploying 5G to access the system, I think.
Yeah. Actually, while option 3 are not used widely. One reason is that our LTE base station is the data split. You know, our LTE base station is 4G base station. It just can support the 100 Mbps. 100 Bps. And you know, if we use the 5G service, we may support the 1 Gbps. 1 Gbps. So for LTE base station, it can't support the high throughput, and the IP transmission and the base station it can't support this high throughput service. So if we just want to update the software, it can't meet our requirement. Can't meet our requirement. So this mode is also not used widely, and the capacity is limited. And the option 3A and the split and the data split in the EPC in data split in EPC, and the data split is fixed. Is not flexible. Not flexible. So it's also not used widely. But for option 3X, the real network uses this mode for coverage. It's flexible and can support a high throughput service. Okay, this is the reason why we use this option 3X. Okay, let's make some question. And the first one, we can select the NSA or SA. NSA or SA. Select SA. And the first one, support a new service such as URLLC. And the first one is NSA or SA. You can tell me your answer.
SA.
Any question? Any answer?
SA.
Yeah, it should be SA.
It should be SA.
The first one is SA or NSA. Please tell me.
SA.
SA. Okay. SA. Yes. Right. Because for our URLLC this service, the SA networking are supported. The NSA just support the EMBB scenarios. Okay. The second one, decouple from the existing 4G network. This is NSA or SA.
NSA.
NSA. I think it's NSA.
NSA.
Should be SA.
Because here we need 4G. So it's NSA.
No, it say decoupled from the existing 4G. So that means separate.
Yeah, but decoupling from existing 4G.
So it should be SA.
Yes,
It
NSA.
should be standalone.
No, because you see 5G not can covering all base stations, so need to decoupling to increase the coverage area.
It is standalone, SA.
Yeah, that's right. Decoupling means separation. That's right. SA. Sorry.
Yeah, decouple from the existing 4G network. This is the SA, because the NSA, the NSA must deploy with the 4G, 4G base station. Yeah. And the third one, the protocol is frozen by the end of 2017, so the 5G can be deployed earlier.
This is NSA.
NSA.
NSA, this one.
NSA.
Yeah.
NSA
Answer is NSA.
Yes,
NSA.
of course.
NSA. NSA. And the first one, the agreement is frozen in 2018.
SA.
Which agreement, please, Mr. Pilar? Which agreement?
Should be SA.
SA or NSA?
SA.
NSA.
NSA.
NSA. Because it's
Standalone.
SA. Yeah,
SA.
standalone.
NSA.
This one is phase 1.2.
Yeah, phase 1.2. This is the SA.
SA.
Yes, yeah. And the fifth, the continuous coverage is required for 5G base station.
SA.
NSA.
SA.
Yes,
SA.
NSA. SA.
Yeah.
SA.
Yeah, SA. And the sixth, less the investment at the early stage of 5G deployment.
NSA.
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 NSA. And the last one, required to deploy the NGC, and the deployment period is long.
This one is
SA.
SA.
Yeah, the right answer is SA. Okay, I think everyone is clearly about the SA and the NSA. Yeah, clearly about SA and NSA.
Okay, it's clear.
Yeah.
Thank you.
Yes, it is clear.
Okay. And URLLC, explore the service the requirement. And the URLLC is to provide us low latency, provide at low latency, because some service need low latency. For example, to control the car, automatic driving or remote driving, like remote driving. This chunk in the Hashman environment, we want to control this chunk remotely. We need a low latency. So we need to make the end-to-end latency as small as possible, and we can see that this car with the radio communication to our base station, like this car and the signal through our base station, through our IP transmission to the core network, and to the V2X server. V2X server. We need the latency as small as possible. For example, if the air interface delay 1 millisecond, and as transmission delay is 5 milliseconds, and the core network millisecond. Core network delay is 2 milliseconds, and the total delay is 8 millisecond. This can support, can meet the requirement, the remote driving. At the beginning time, I said the end-to-end 1 millisecond, end-to-end 1 millisecond delay, end-to-end. But for the real world, it's very difficult to realize because the delay in air interface have the delay, and IP transmission also have delay, and the NGC, core network, also have the delay. But maybe in the future, we deploy the MEC, mobile edge center, mobile edge computing near the car or near the user. They can delay the latency, decrease the delay. Like in our smart manufacturing, we also need low latency to control the robot, control this machine. And in the cloud service AI robot, we also if we want to control the robot, we also need a low latency. And if the delay is too long, it may hurt old man. It's very dangerous. So this is why we need the URLLC, low latency. Okay, let's have a short break. Okay, have any question?
Yes, please. Actually, on your slide, you see the database capacity. Could you clarify to us which kind of database do you use to address this kind of applications? So, do you use, for example, big data, or you don't have to go to use this kind of database?
Sorry, I can't get your point.
Yeah, you're seeing here, like you say, database capability, yes?
Database
capability, yes?
Database capability. This one.
Yes, this one. Yes, this one. So, I mean, like, which kind of database do you use to address, all of these services? So, do you have to go through, big data, for example, or you don't have to use it? For example, if you say Oracle database might address, all of these things. So, which kind of database do you use for this issue?
Database. Yeah. Actually, maybe in the future we will deploy the MEC, and the data center will deploy near the base station. Actually, near the application. And it can protect the data security, and also can decrease the latency, delay.
Mm-hmm. Okay, thank you.
Okay, let's have a short break, 10 minutes.